Welcome back to this module 4 of MOOC's blockchain course. Up till now, we have seen in module 4 what is Remix ID. In this lecture today, we'll be seeing the basics of a smart contract written in a Solidity programming language. A smart contract is a key factor which acts as an interface between a blockchain platform and a GUI application created on the blockchain. We'll be writing the smart contract using the Remix ID and the language would be Solidity. So let's see about the basics concept of Solidity language and how does a smart contract looks like. The window open over here, you can see this code is a Solidity code. So let's first understand the selected code. It has been written in the Remix ID, which we have already seen in the previous lecture. What is a Remix ID and what are the different tools which are available in Remix ID. We'll be seeing more of the remix in the coming videos and also in today's video. First, let's concentrate on the smart contract. The first line of the code, pragma solidity. Any contract, any program in Solidity language starts with this line pragma solidity. It gives us the compiler version to which the code is compatible with. Solidity is an evolving language. It is changing a lot and a large number of compiler versions are there for Solidity language. We are using a very old compiler version. Just for reference, the number is 0.4.0. So the coding language changes depending upon the compiler version. There may be certain slight change with new compiler versions. So a programmer has to mention in the very first line that the code is compatible with which compiler version. For example, the code which is written in front is compatible for 0.4.0. Now the first line is pragma solidity. After it, the keyword is written, that is a contract, and after this keyword contract we have to give the name of the contract. You can give any name to the contract as you wish. For this example, we have given the name person. What is this contract about is, the contract is a simple contract where we are saving the name and age of a person. A blockchain is a chain of blocks which is used to store the data. Just to give a demonstration over here, we have created a contract which is saving the name and age of a person. So in this video, in this lecture, we'll be studying about the contract, and then in the coming sessions, we'll be compiling it and seeing how does it appears on an actual Ethereum platform. Now, the third line and the further lines over here, these are the data types of Solidity language. It is difficult to complete and cover the entire Solidity language. We'll be showing 2-3 smart contracts to give the basics of Solidity language. The string and uint are two data types. A string represents a group of characters and uint is for unsigned integer. Unsigned integer. As you must have studied other programming languages also, private, public. So these are some of the access specifiers. Similarly, they work in the same fashion as they have worked in the previous language, which we believe you must have learned before. So this is the name of the variable, name and age. These are the two names of two different variables, and name is of type string and uint means unsigned integer is of type age. And then a language, a Solidity language, we write a contract. A contract is made of data and function. So these are the data, these are the variables, and to access these data, there are different functions. To write a function, the first keyword which is written is called as a function. After this function, we have to give the name to the function. You can give any name to the function. Generally in Solidity, Functions are divided in two categories. One are known as setters and others are known as getters. Setters are used to give any input to the variable, and getters are there which are used to retrieve the value. Now this set name is a function. These are the arguments which is passed, a string new name, and it is of type public. It means that it can be accessed outside the contract. It can be accessed outside the contract. And the new name which will be given to from the Ethereum platform, it will be given to the variable name. When we'll be running this contract, we'll be giving a name, the user will be entering a name, and the name will be given to the new name variable, which will be assigned to the name variable. Similarly, there is another function which is a get name, which is used to retrieve the value which has been inputted. So it will display the name which has been given by the user. It will be displaying the name which has been given by the user. Similarly, it is set age. Set age is going to give an age, and get age is going to retrieve the age which has been given by the user. So after this, we end with the contract by putting the curly braces. So this is a small code where four functions have been written and two data types have been used using a Solidity language. Now to proceed further, let's see that how do we compile this code, and then we'll be doing certain changes to learn more about the smart contracts and Solidity language in further lectures. Now how to compile this code? So for compilation of this code, the first symbol is File Explorer, the second symbol is for compilation of the code. So we click on the second symbol that is on the compile code, and we choose the compiler version. So the compiler version we have written 0.4.0. So it is compatible with 0.4.0, 0.4.1, 0.4.8. So it is compatible. So let's choose 0.4.6. Let's choose 0.4.6. Language, it comes by default Solidity. If there is no error in the program, when we will click on this compile first.l, the code would be compiled. So let's click on compile. As soon as we click on compile, the Solidity program has compiled and it has resulted in two files. One is application binary interface and second is a byte code. This application binary interface, this is basically an interface which is required when we make the front end, when we make the Web3 front end for this smart contract to make an application, to make a dApp. So this ABI is automatically generated when we click on compile and the name of the file. If we click on this compilation details, we will be seeing different details which has been generated by the compiler. For example, the name of the contract person, the metadata, the byte code, it has been converted into the byte code, the application binary interface, and other details are also visible. So to learn more, it is advised that open this compilation details and go through the details which are available on compilation. Now let's deploy the contract. After compiling, the second task is to deploy the contract. Now how to deploy? Click on this third button of deploy. Over here we have to choose an environment where we wish to deploy the contract. There are different environments which are available. If we click on environment, let me explain what does it information does it give. The JavaScript virtual machine is basically your local machine, the Ethereum virtual machine, which has been provided by the Remix ID. It will not be deploying your contract to any Ethereum network in reality. You will only be testing it on a virtual machine. If you wish to deploy it on some testing network like we have seen in MetaMask, you have to choose injected Web3. So let's choose injected Web3. As soon as we have taken injected Web3, it asks for it that connect with MetaMask. So it says that do you want to connect with MetaMask? We said yes, connect with MetaMask, and it is being connected with MetaMask. So it gives that Go early network. So it has been connected with the Go early network. If we wish to switch to some other network instead of Go early network, then we can click on this MetaMask icon over here and we can change the network. For example, if I take ring B test network, you will find very soon that it goes over here and gives ring B test network, ring B network. So to have a more elaborative view and to have a feeling that yes, a blockchain has been created into a Ethereum network, we choose a test network and we'll be deploying it on a ring B test network. For deployment on a main Ethereum network, we require actual ethers. So for testing purpose, we are using a ring B test network. Now this account address, which is visible over here, this account address which is visible over here is your account address of ring B network, or you can say your MetaMask address. This is your MetaMask address. This is your MetaMask address. So it is having a 19 ethers over here, you can see. So it is having 19 ethers over here. So this is your ring B test network. What is this gas limit? Let's talk a little bit about the gas. Whenever we write a contract and whenever we deploy a contract, the Ethereum network deducts certain transaction fees. These transaction fees is used as an incentive for the miners. The transaction fees is represented in a unit which is known as way. One way is equals to 10 to the power minus 18 ethers. And this transaction fees is represented by a term which is known as a gas. The gas fees taken for any transaction, for any deployment of a smart contract, depends upon the complexity of that smart contract. So after choosing, we don't have to change any limit or anything. We just have to click on deploy. When we will be clicking on deploy, it will be taking a confirmation from the MetaMask as you can see on the screen. And when we will confirm this thing, that you can see that this much amount of maximum fees and this much amount of fees has been taken will be deducted. And when we confirm on it, after getting the confirmation, the miners will approve, and depending upon the speed, it will take certain time and the contracts would be deployed and it would be visible over here. It would be visible over here. The deployed contracts would be visible over here. Yes, now it has been deployed and you can see a message has come that confirmed transaction 0 confirmed. We can view it also on ring B Etherscan and the contract has been deployed. If I click over here, it says that the contract has been deployed, and these are the various features that how we can use the deployed contract. So in the next video, we'll be focusing on that how we can run and see that the deployed contract. In the next video, we'll be seeing that how we have deployed the contract, how we can use this deployed contract, the features of age and name, how we can use this contract. So to summarize with, in this video, we have seen that how we can compile a smart contract, how we can deploy a smart contract, and we have also seen the very basics of Solidity language. Thank you and have a happy learning.